Objective 2 in this section, we're going to move on from multiplying to dividing. Now, we've already done a lot of dividing with radicals, so these are going to be very specific division questions where you end up with a radical in the denominator. And if you remember way back to that lesson on simplifying, the rule was you couldn't have any fractions under a radical. And not only that, but even if we rewrote this as root 3 over root 7, there's a rule that you're not allowed to have a radical in the denominator. So this lesson is all about how to get rid of radicals in the denominator. So we're going to start with monomial denominators. So we're going to start with rationalizing, so getting rid of the irrational number, making it rational. So we're going to rationalize denominators with one radical term in them. So to do that, there's two ways to accomplish it. Number one, you're going to multiply the top and the bottom by the radical in the denominator. Or you can multiply the top and the bottom by something to create a perfect square in the denominator. And I'll show you what I mean by that. So if you look at this guy here, this has already been simplified. You've got 9 divided by root 3. Would be fine, except that you're not allowed to be left with a radical in the denominator. So we are going to multiply the top and the bottom by the same thing. And that same thing is whatever we can multiply by to make this denominator a perfect square. So if I multiply by itself, root 3 over root 3, you're going to end up with 9 root 3 in the numerator, because it's 9 times root 3. And then on the bottom, you end up with root 3 times root 3, which is root 9. If you simplify the square root of 9, you end up with 3. So then you end up with 9 divided by 3 is 3, and you can simplify this to 3 root 3. So again, this is just a process of simplifying. 9 divided by root 3, if you type this into your calculator, you're going to get the same as if you typed in 3 times root 3. Okay, next one, we've got 6 divided by root 2. Again, what's wrong with this is that we have a radical in the denominator. So we're going to multiply the top and the bottom by the radical in the denominator. It's the easiest way to go, because if you multiply something by itself, you end up with this perfect square. So you're going to multiply by root 2 over root 2. So on the top, you're going to have 6 times root 2. On the bottom, you've got root 2 times root 2 is root 4. And then you end up with 6 times root 2 divided by 2. Now you can simplify. 6 divided by 2 is 3 root 2. So in both of these, by multiplying by itself, you ended up with a perfect square in the denominator. And you can skip this step if you want. If you realize that in the denominator, you're getting root 3 squared, then the square and the square root, if you wrote that as, so let's keep this right, if you wrote this as a rational exponent, you'd end up with 3 to the 2, and then the index becomes the denominator, right? So you end up with a 1. So anytime you times a radical by itself, you end up with just the number that's under the radical sign. So if you don't want to do this step, or maybe you like the looks of this step instead, so instead of writing root 9, you could write root 3 squared, or you could jump right to writing a 3. That's entirely up to you. Okay, next question. So this one, I hope you recognize that this would be the same as root 3 over root 7. So to get rid of the radical in the denominator, we're going to multiply by it. So we're going to multiply by root 7 over root 7. You end up with root 3 times root 7 is root 21. And then on the bottom, again, root 7 times root 7 is just 7. Or you can go through the process of writing root 49 and then getting root 7, or you could write it as root 7 all squared, and then you'd end up with 7 still. Now, double check you can't go any further. Is 21 simplifiable? Is there a perfect square that divides evenly into 21? No. So we move on. So this one, we're going to multiply by the radical in the denominator again. So root 5x, root 5x. You end up with 2 times root 5x all over. And again, you can just write 5x here if you're ready for it. If not, you could multiply and get 25x squared, and then you can simplify it. You've got 2 times root 5x all over 5x. And then look to see if you can simplify the rational numbers in the end. And of course, this one, x cannot equal 0, and it actually has to be greater than 0. Don't go there. Okay. So let's look at these questions. So we've got something like -8 divided by root 18. The process that I just showed you were all number ones. You multiply by the radical in the denominator. And that's because the radical that was in the denominator, they were all these like kind of small prime numbers. And so what we're going to do now is, what are we going to do when it looks like something like root 18? And you have two choices. Choice number one, you can simplify first. So I can look at this question and say, okay, I see that root 18 is going to simplify into two radicals. The highest perfect square that goes into 18 is 9 times 2. So I'd end up with -8 over the square root of 9 is 3 root 2. Then I can do the process number one. I could say, okay, I'm going to multiply by root 2 over root 2. I end up with -8 root 2 all over 3, and then root 2 times root 2 is root 4. In other words, I end up with -8 root 2 all over 3 times 2. And now maybe I notice that I can do 8 divided by 2 is 4, and this is going to simplify to -4 root 2 all over 3. Now again, you can check to make sure you did this right, because if you plug into your calculator -8 divided by -18, you will get the same answer as if you plug in -4 times root 2 all over 3. Now that's method one. So I mentioned if you wanted to do it the same way as we did in the first one, so number one, you can just simplify your radical and then multiply by the radical in the denominator. Option number two is that you can multiply by whatever you want. So you could multiply by something that would turn 18 into a perfect square. So for example, if I look at it, if I do 18 times 2, 18 times 2, it's 36. So what if I took this expression and I multiplied it by root 2 over root 2? Then I would get -8 root 2 all over root 36. So then I could say, okay, -8 root 2 all over square root of 36 is 6. And now I can simplify my rational numbers. 8 divided by 2 is 4. 6 divided by 2 is 3. You get -4 root 2 over 3. That's another option. Some people, I'm going to erase this in a second because I wouldn't do it this way. Some people are like, I'm going to multiply by the radical in the denominator. So you can multiply by root 18 over root 18 if you really want. Then you get -8 root 18 all over root 18 times root 18. I'm just going to write 18 here. You can do it this way. And then you can simplify root 18 to get root 9 root 2. All over 18, you'd get -8 times 3 times root 2 all over 18, and then you'd have to simplify this. So 3 goes into itself once and into 18 6 times. 2 goes into 6 twice and into 8 4 times, but you still get -4 times root 2 over, oh sorry, that was supposed to be goes into 3 times, sorry. Too much simplifying and I'm bound to make a simple mistake. But the moral of the story is your job is to get rid of the radical in the denominator. So you're multiplying by something to create a perfect square in your denominator so that you get rid of your radical. Whether you see it as simplifying and then multiplying by the radical in the denominator, or you say, what can I multiply by to make that a perfect square? Or whether you just like multiply by whatever's in the denominator. It's up to you. Okay, so next question. I'm just going to erase what I have here so that I have room. Sorry, one second. So in this next question, you've got root 9 over root 8. So if I look at this question, I'm going to first of all separate it into root 9 divided by root 8. And again, I like simplifying first, so I'm going to write this as 3 over square root of 4 times square root of 2. Gives me 3 over 2 root 2. Now I'm going to multiply by the radical in the denominator. So it doesn't matter if there's a coefficient, you just multiply by the radical. So you end up with 3 root 2 all over 2 times root 4. So you'd end up with 3 root 2 all over 2 times the square root of 4 is 2. So 2 times 2 is 4. And that's your final answer. Or, when you were at this step here where you had 3 over root 8, you could ask yourself, what do I multiply 8 by to make it a perfect square? Well, I know that 16 is a perfect square, so if I multiply by root 2 over 2 root 2, that'll work. I get 3 root 2 all over the square root of 16, which is 3 root 2 over 4. Doesn't matter, you know, whatever you see to do. Some people just get in this simplification habit, in which case simplify first. Simplifying first is a great habit to have. Okay, so let's try this one. Okay, this one, when I'm looking at it, first thing I'm going to do is split it up into 8x cubed divided by root 3y cubed. Again, you could right now sort of go for it. You could multiply by the radical in the denominator because you could simplify first. You know, it's kind of whatever your instincts are. I always like to simplify, so I'm going to simplify first. So I'm going to look at 8x cubed, and the highest perfect square that goes into 8 is 4 with a 2 remainder. Then I've got an x cubed, which is bigger than my index of 2, so I'm going to put the x squared in the first radical and the x left over. And in the denominator, I'm going to do the same thing. 3 is prime, so it's going to go over here. And then the highest perfect square that goes into y cubed is y squared with a y factor remaining. Then I'm going to simplify. I've got 2x root 2x over y root 3y. Now, this is simplified, but it has a radical in the denominator. So we have to get rid of that. So now I'm going to multiply by root 3y over root 3y. I end up on the numerator, in the numerator, you're going to multiply your radicals together. So you get root 6xy. And in the denominator, you've got this y out front. Then you've got root 3y times root 3y. Maybe you're ready to say, okay, that's just 3y. Whenever you multiply something by itself, then you end up with the answer into the square root sign. And then to finish this off, you'd have 2x root 6xy all over 3y squared. So remember, the last question in an example is the hardest one. So you're going to build up to this in your homework. You're going to start back here at questions that look like this, where you just have a number divided by a radical and you multiply by the radical in the denominator. It'll start slow, and then just like this lesson, it'll gradually creep up into something that looks like this. Before I stop the video though, I just wanted to mention the other thing. You know, maybe you look at this and say, I want to make a perfect square down here. I don't want to simplify first. So to turn 3 into a perfect square, if I multiply 3 by 3, I get 9. Now to make y cubed into a perfect square, you could actually just multiply by y. So if I do that top and bottom, I wish I could change colors. Okay, so if I do that top and bottom, I'm going to end up on the top with root 24x cubed y. And in the denominator, I would end up with 3 times 3 is 9, y cubed times y is y to the 4. And then I would simplify. Simplifying my radical in my numerator, the highest perfect square that goes into 24 is 4 with a remainder of 6. And then x cubed would give me an x squared with an x and then the y. And then the denominator, the square root of 9 is 3, square root of y squared is, or y to the 4 is y squared. So I'd end up with 2x root 6xy all over 3y squared. So hopefully that hasn't confused you, but the moral of the story is you are rationalizing denominators. You are turning irrational denominators into rational numbers. 2 options. You could multiply by the radical in the denominator, or you could multiply by something that will create a perfect square in the denominator. Entirely up to you.